All right, so this first one here is a good example to go through for these sigmatropic reactions because it's not yet oriented in that ring structure that's going to form. So we're going to have to rotate about these bonds, the single bonds, and make sure that they're pointed all in the same direction, right? So I want to go through an example real quick. First thing I would notice is I'm just going to number this, not like number it for stereochemistry, but just so we can keep track of everything here. And the important thing about this molecule and why it undergoes is because it has that perfect spacing between these double bonds, right? So this is going to be all the members of that new ring that's formed. I have that 1,5 spacing, but of course in this one, because there are more carbons, it's 2,6. But point being is they're located at correct distance apart. So I know that these are going to form a ring. So what I'm going to do is sort of just start out with forming a 6-membered ring, right? A hexagon. Actually, let me do a different numbering system just for this ring too. 6, 1, 2, 3, 4, 5, 6. And then you go through and make sure that everybody's connected correctly. Most notably, right, atom 4 in this ring, or 5 in the whole structure, is an oxygen. And then 1 and 6 are the only ones that aren't going to be connected. And then 1 and 2 have that double bond, and 5 and 6 have that double bond. So now I'm just missing these atoms over here in order to make this correct. And I've just rotated about the single bonds here, right? I haven't actually done any chemistry. I'm just putting it in that correct orientation to do the reaction. The important thing to make sure is that if you start out with a cis or a trans bond in one structure, it's going to be cis or trans after you've rotated it. So this bond is trans between carbons. Well, I guess I can switch back to my whole numbering system here. These would be 2, 3, 4, 5, 6, 7. So bottom line is this one needs to be pointed up instead of out in a cis conformation because it's trans. And likewise, same thing over here. So then we're just going to go through now with the sigmatropic reaction. For these ones, they're kind of weird because you're breaking a single bond. I think the easiest thing to do is start with the first step to remember that you're going to create your single bond or shoot this gap, right? You're going to cross over. It actually doesn't matter which direction you went, but you're going to shoot that gap and then just make sure everything goes in a circle, right? The head of one arrow should be connected to the tail of another. And then here's the weird part is that we actually break this sigma bond and ended up at that atom there. So now I have this molecule here, where here is the bond that was formed, right? Should be there. And the bond that's broken, that's now missing, is that one there.